Welcome, class. Today we're going to observe and analyze a demonstration of the Flour Cocoa Powder Asteroid Impact Lab. For those of you here at school, you will be able to do this live with us. For those of you participating remotely or out sick, you can follow along with the lesson and later have the fun of making messes and getting dirty by creating your own lab. Recall there will be a mastery check over your mastery of the science concepts taught. In our problem-based unit, Alabraska, you're going to need to have mastered these concepts to build a safe cavern in a good location to save the people of Alabraska from the asteroid. Let's get started. But first, let me show you my class doing the same lab.
Guys. Okay, go.
What?
Oh! That thing is more than 100 centimeters!
First, you're going to need to gather your materials. This is going to include a couple of marbles, a container. We used disposable aluminum casserole containers, but you could use a box or whatever you have on hand, a meter stick, a ruler, a couple of bags of flour, several bags of cocoa powder, and a measuring cup. A kitchen or other easy to clean area is a good idea, as is preparing your work surface with a layer of newspaper or butcher paper for easy cleanup. To set up for your lab, this is what you're going to need to do. You're going to need to fill a pan with flour and cover the flour-filled pan with a layer of cocoa powder. Go ahead and set up a layer of newspaper or butcher paper under the pan as well as under the table if needed. We have a tile floor in the classroom, so it's okay to get messy. Stand in the same spot each time, holding the marbles at arm's length over the pan and drop the marble. For the first 3 trials, you're going to raise your marble up 30 centimeters from the ground. For the next 3 trials, you're going to drop it from a height of 60 centimeters. And for the last 3 trials, you're going to drop it from a height of 90 centimeters. Make sure you're dropping it from the same spot each time and just changing the height. You can measure up to the drop point with your meter stick. After the marble lands, you are going to measure both the distance across the depression in the crater and how far out the flour flies and lands. Complete your measurement table with the data as you go. Okay, our problem's about asteroids hitting Earth and saving people in a particular community. So we really need to know what asteroids are and what they do when they hit Earth. So in this lab, we are simulating what it is when an impact crater forms and what happens. An impact crater is a depression in the Earth formed after an asteroid collides with the Earth. In our experiment, the marble is going to be representing that asteroid impacting the Earth. The cocoa powder and the flour are going to show you how various layers of the Earth are changed by the impact of the crater. We are going to keep all these controlled variables, like the ingredients used, the way the marble is dropped, the way we measure the craters. Those are all going to stay the same. The only thing we are changing for this lab is the independent variable. That's the height of the drop. So here's the nitty-gritty about an asteroid crater. Asteroid craters have parts. Every asteroid crater has a few features in common, while some craters have additional features that make their craters complex. All impact craters have a floor. That's that smooth bottom of the crater. Walls, just what it sounds like, the steep inside walls of the crater. The rim, that's the edge of the crater. And ejecta. That might sound familiar to you because it sounds like eject. So that's going to be the material that is thrown out of the crater by the impact. Some craters also have rays of debris that radiate out from the impact site, while large craters may contain a single or multiple central peaks. Those are also kind of just what they sound like. It's going to be a peak, kind of like a mountaintop. Here, you can see both a diagram of a real asteroid impact crater and our model with the flour and the cocoa powder and where the marbles have landed. Remember, after each trial of the dropping your marble in the impact crater, you're going to gently remove the marble and then measure down into that crater to see how far it goes. Okay. Now you've learned everything about asteroids, impacts, and everything in between. It's time for you to go try it out for yourselves. If you're in class, get together with your group, grab your lab sheet, and set up for your lab. If you're at home, you can set up on your own, or you could even find a demonstration online if you don't have any materials. But I recommend you really try out the lab. It's a whole lot of fun. Let's talk about this lab sheet so you can feel confident getting going. Okay, on page 1, you're going to make a hypothesis. You're going to guesstimate or make a guess. If a meteorite is dropped from blank, blank is going to happen, right? So remember, what we're changing is that height of that marble, that height of the asteroid. Okay, what do you think's going to happen the higher the marble is raised? What's going to happen when it drops? What's going to happen to the diameter of the crater? What's going to happen to that ejecta that comes out? Remember, those independent variable is going to be that only thing that changes, that one thing you're going to change each time. But the dependent variables are going to be all those things that stay the same, right? And there's going to be a table where you're going to record all your results. You're going to record 3 trials of the diameter of the crater. That's just you're going to be measuring from the start of that little circular indent uh, when you've dropped it from 30 centimeters. You're going to do that 3 times, take an average of the tries so you can come up with what that average was. So you're going to add those 3 tries up. Maybe it's 2 centimeters, 3 centimeters, and 2.5 centimeters, right? Add them all up, divide by 3, you're going to get that average. Okay. And then you're going to, while you're doing that each time, you're going to also record the distance of the ray. How far does that stuff spread out? It's helpful to have someone else to be watching that for you and kind of mark with a toothpick or something where the stuff that spews out lands, so that then it's easier for you to get that meter stick and start with that center of where the marble caved in to where that cocoa mixed with the flour flew out. All right, you're going to do that 3 times for 30, 3 times from that height with your arm raised out straight of 60 centimeters, and 3 times from 90. Okay, and then you're going to have some post-lab questions. Okay, after seeing what happens, what is the relationship that you found out between the height of the meteorite it dropped from and the size of the crater? Also, what is the relationship between the height that the meteorite was dropped from and the distance of the ejector ray, how far that stuff flew out? I also give you plenty of space to give all your analyses and a final conclusion. I really look forward to seeing how you do. And if you have any questions along the way, don't feel hesitant at all about going back to the beginning of this video, watching it all again. You can even watch that fabulous drop from that 90 centimeter mark that my kids were so excited about, and submit it in Google Classroom. Have fun and get messy, but clean up afterwards. See you next time.